Good morning, children. I hope that you all are studying hard at home and utilizing your time constructively. Today, we will discuss one of the most important topic of real number, that is irrational number. So, what are irrational numbers? Irrational numbers are those numbers which cannot be expressed in the form of p by q. Now we are going to prove question number 1 of exercise 1.3, which is prove that root 5 is irrational. But before proving it, we must know the meaning of coprime. All of you know about rational numbers or fractions. 1 upon 3, 3 upon 4, 4 upon 12, 5 upon 25. These all are rational numbers. But in the first two example, you can see there is no other common factor except 1. You cannot reduce it into the lowest form. But in the last two, you can see 4 is a common factor between 4 and 12. We can cancel it out. Similarly, in the last one, 5 1 ja 5, 5 5 ja 25. So, these are co-primes. 1 upon 3, 3 upon 4, 1 upon 2. These are co-primes which cannot be expressed further in lowest form. So, what are co-prime? Co-primes are those rational numbers where there is no common factor of numerator and denominator except 1. Next theorem is that if a square is divisible by 3, then a is also divisible by 3. I am explaining you by an example. Suppose 36 is divisible by 3. You can see 3 12 are 36. In place of 36 we can write 6 square is divisible by 3. So 6 is also divisible by 3. You can take any other example. Suppose 5 square, which is 25, is divisible by 5. So you can see 5 is also divisible by 5. Now we are going to prove root 5 is irrational. Let us assume to the contrary that root 5 is rational. We have to prove that it is irrational, but we are assuming that root 5 is rational. And if it is rational, then we can write root 5 in the form of p upon q, where q is not equals to 0, and the important part where p and q are coprime. To prove this question, this is important that P and Q are co-prime. Now cross multiplication, we can write this as Q into root 5 equals to P. Q into root 5 equals to P. Squaring both the sides, we will get Q square of under root 5 is 5 equals to P square. This is equation number 1. Now what does it mean? Q square equals to P square upon 5. We can write this. So it means that P square is divisible by 5, and if P square is divisible by 5, then P is also divisible by 5. This is equation number 2. Now if P is divisible by 5, so we can write P equals to 5m. For an example, if 12 is divisible by 3, if 12 is divisible by 3, so we can write 12 equals to 3 into 4, 3 4s are 12. Similarly, if P is divisible by 5, so we can write P equals to 5m. Now again squaring both the sides, we will get P square equals to 25 m square. Now from equation 1, in place of P square we can put this value. So it is Q square into 5 equals to 25 m square. Now 5 5s are 25, so this can be written as Q square equals to 5 m square. Again, what is the meaning of this equation? Q square equals to 5m square means Q square is divisible by 5, and if Q square is divisible by 5, Q is also divisible by 5. So this is equation number 3. Now from equation 2 and 3, you can see that 5 is a common factor of P and Q. But in the beginning of this question, you have mentioned that P and Q are co-prime. So there cannot be any common factor. So from equation 2 and 3, P and Q have at least 5 as a common factor. But this contradicts the fact that P and Q are co-prime. This contradiction has arisen because of our incorrect assumption that root 5 is rational. So we conclude that root 5 is irrational. Next question is, prove that 2 plus root 3 is irrational. Now this type of question, if you have been asked in the board exam that first you have to prove that root 3 is irrational, Then prove that 2 plus root 3 is irrational. Then you will show that root 3 is irrational. Then after that. But if it is directly asking that prove that 2 plus root 3 is irrational, you need not to prove that root 3 is irrational. Again the working is same but slightly convenient to you. We will assume that 2 plus root 3 is rational. In the contrary, now if 2 plus root 3 is rational, then we can write 2 plus root 3 in the form of P upon Q, where Q is not equals to 0. Now, what are you have to supposed to do is that you have to find the value of root 3. So, root 3 equals to P upon Q, and 2 will be shifted to right hand side. If you will take Q as LCM, it will be P minus 2Q. So root 3 will be equals to P minus 2Q upon Q. Now since 2, P and Q are integers, since P, 2 and Q are integers, so right hand side, that is P minus 2Q upon Q is rational. P minus 2Q upon Q is rational. But this contradicts the fact that root 3 is irrational. So irrational number cannot be equals to rational number. So we conclude that 2 plus root 3 is irrational because our assumption is wrong. So by this you can do exercise 1.3 question number 2 and 3, and reference sums you have to prove that root 7, root 11, root 13 are irrational numbers. Thank you children. Stay home, be safe.